Science Fantastic with Professor Michio Kaku. Every week on Science Fantastic, we profile some of the most amazing developments in science and technology that touch our lives and affect the way we see the universe. Well, today we're going to bring on an artist and also a science writer who's written a gorgeous new book. I've seen a lot of books on exoplanets, that is, planets orbiting around other star systems, but this by far is the prettiest as well as the most authoritative look at other worlds in outer space. The book is called Envisioning Exoplanets, Searching for Life in the Galaxy by Michael Carroll. He has the distinction of being not just a science writer, he's also a science artist as well. A member of NASA's arts program, he's received a number of awards from the American Astronomical Society and the International Association of Astronomical Artists, and we'll be talking today about his gorgeous picture book about other worlds in our galaxy. So, Michael, glad you could be on Science Fantastic.
Oh, Dr. Kaku, it is my privilege. I enjoy the show. I enjoy your work very much.
Okay, first question for you is, when you were a kid, a youth, what steered you in the direction of science and also art?
Well, both of my parents were interested in art. They were very creative. My father was in aerospace, and one of my earliest childhood memories was sitting on his shoulders in the backyard in Colorado, looking up at the night sky and seeing a moving star, and he pointed it out and said that is called Echo 1. It's one of the very first satellites, and I said, why just Echo 1? And he said, oh, because there will be more. And of course he was right.
And then what steered you in the direction of becoming a professional artist and also science writer?
Well, you know, I love the sciences, but I'm terrible at math, and have always loved the arts as well. And the visual side of exploration and of space exploration in particular has always intrigued me, the new frontier out there. And so art enables us to go there to see things on a human scale that we may have only seen at hundreds of thousands or millions of miles range through the eyes of telescopes or spacecraft.
You know, when I was a youth years ago, I saw the work of Chesley Bonestell, a science artist who drew these fantastic images of what it'd be like on Saturn and Jupiter and throughout the universe. And I think you're carrying on that tradition because your book, Envisioning Exoplanets, is gorgeous. It's a gorgeous color book with lots of scientific commentary as well as pictures by the artist himself. Well, in your book, you start with history, and you start with Giordano Bruno, who met a very unfortunate fate. So tell us a little bit about what happened to the life of Giordano Bruno, who essentially set the pace for the next several hundred years.
Well, he really did. At the time, the church did not have any official standing on Copernicus's ideas of a sun-centered solar system, but Bruno was one of the first to say, hey, the stars out there are probably suns. And if they are suns, they probably have planets going around them. He was way ahead of his time, and certainly brave enough to say these very strange ideas to a society, a culture that had yet to accept them. So he was not a scientist, he was a theologian primarily, but he certainly got that right, and it's inspiring to see the insights that people of other ages get by observing nature. I love that.
And you mentioned how sad his fate was, that he was put on trial for heresy, talking about life in outer space. and he was stripped naked, burned alive in the streets of Rome in the year 1600. And even today, when you walk to the Plain of Flowers in Rome, which I did a few years ago, you can go to the exact spot where Giordano was burned alive, and there's a statue of Giordano Bruno marking the extraordinary life of a prophet who actually talked about one day we would explore outer space and, who knows, maybe one day encounter life throughout the universe.
Yeah, isn't that amazing? Yeah, the vision that he had, and the idea that there is a frontier beyond the one that we see here on Earth. He looked up at the night sky and saw wonders and possibility, and I think studying exoplanets and studying other worlds helps us to do that. It gets us out of ourselves.
Now, when I was a kid, I remember having a book about astronomy, my first book. You take out stamps of Saturn and Mars, and place it on the book. And the book more or less concluded that our solar system was probably average. That is, we have rocky planets toward the center in circular orbits, gas giants further out, also in circular orbits, and then maybe comets beyond that. Well, boy, were we wrong. We are the oddballs in outer space. So to give away the conclusion, have we found a twin of our solar system in the galaxy, or are we really the oddball?
It's a great question, and it's the question that really drives a lot of the study of exoplanets. It does turn out that when you look out at the stars at night, 90% of the stars out there are invisible because they are red dwarfs. They're tiny, cool stars, and astronomers assumed that these would probably not have planetary systems, or that they would have systems that were dead. Well, it turns out that the majority of planets that we are finding in that Goldilocks zone, the habitable zone where you can have liquid water on the surface, the majority of those are orbiting red dwarf stars, which are very, very un-sun-like. We have found Earth-sized planets orbiting sun-like stars, and that's very exciting, but they're much more rare.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Michael Carroll, author of a gorgeous book about exoplanets in the galaxy. It will be a great present to give to a loved one who is just beginning to understand the majesty and the splendor of our universe. The book is Envisioning Exoplanets, Searching for Life in the Galaxy. Now, when I was a kid, books said that the idea that there could be other planets out there is a nice idea, but it would never be testable because planets have no starlight of their own. The mother star would have 1 billion times more light being emitted than a planet, which would appear dark. So then the question is, how do we do it? How do we see these dark planets out there that do not give off light of their own? How's it done?
Yeah, there are a couple of different techniques. One is called radial velocity, and this has to do with the nature of light. When a star is moving toward us, its light is shifted toward the blue. It's compacted just as a siren driving by will change tone. Light changes color as it moves, and so if it's coming toward us, it shifts to the blue. If it's going away, it shifts towards the red. If there's a planet orbiting that star, it's going to tug on the star a little bit. We won't see the planet, but we'll see a shift in the light of that star between the red and the blue, and that tells us something about that invisible planet going around. The second way, and what has turned out to be the most successful way, is called the transit technique. Most stars that we see in even the most powerful telescopes are just points of light. We don't see a disk. They're too far away. But we can study that light, and if that light dips in a certain way, we know that a planet is crossing the face of that star. We can, if we see that dip regularly, then we know that it's a planet because it's going by in an orbit. And there are several other things, microlensing and some other techniques, but the Kepler Space Telescope is the one that has made the most discoveries using that transit technique.
Well, we've analyzed about 4,000 exoplanets orbiting other star systems, complements of Kepler. But tell us a little bit about the latest concerning Kepler. I understand that it had problems with stability and it's been phased out, but now we have tests. So tell us a little bit about these marvelous telescopes by which we can actually see evidence of what Giordano Bruno predicted hundreds of years ago.
Yeah. First of all, the Kepler telescope was kind of resurrected because of the cleverness of the engineers. It and many spacecraft are stabilized by things called reaction wheels. They're just a heavy wheel that spins and keeps the spacecraft stable. You typically have 3 or 4 of those, one in reserve, but Kepler lost a couple of them, and so it lost its ability to remain stable. But it has a big solar panel on one side, and they were able to orient the spacecraft so that the pressure of sunlight actually stabilized the spacecraft. Never been done before. Brilliant engineering on the part of the flight engineers who run these things. TESS, as you mentioned, the Transiting Exoplanet Survey Satellite, is one of the next exciting generation of spacecraft that is kind of stepping up what Kepler was able to do. ESA has a spacecraft called Cheops, which actually measures the mass of planets out there, and the James Webb Telescope, which should be coming online in a few years here, will be able, hopefully, to tell us how many solar systems like our own there are out there. It's kind of a Hubble on steroids. So there are others down the road that are on paper right now, very clever designs, and I think in the next 10 to 20 years, we're going to have a lot of surprises, a lot of exciting insights into the nature of the universe out there.
Okay, well, we have so much data from these 4,000 exoplanets that it's possible to take a census of the Milky Way galaxy. The galaxy has 100 billion stars. So tell us now, on average, what percent of the stars in the galaxy that we see every night, what percent of them have planets going around them, maybe large planets, and of them, what fraction of them have planets that look somewhat like the Earth? So if you were to take a census of the galaxy tonight, when you look at the night sky, what fraction of these stars, on average, have planets?
Yeah, I don't have those numbers with me, but I'm going to guess the vast majority of stars out there have planets, even multiple star systems. The sun is an outlier, as you said earlier, in that it's all by itself. Most star systems have multiple stars, and it was thought that you couldn't have stable planetary systems. Now we know that's not true. So even in these strange multiple star systems, we have stable planetary systems, and that bumps the number way up. So the majority of stars out there have planets. The confirmed exoplanets about a year and a half ago were 2,300, and now we're up to about 4,000 just over the last year. So it's pretty spectacular the how many just plain planets there are, and then of those, Earth-like planets are a fairly small fraction, but the numbers are so great that we're looking at hundreds of millions of Earth-like planets out just in our Milky Way galaxy.
Okay, well, the textbooks talking about our solar system say that at the center we have rocky planets, Mercury, Venus, Earth, Mars. Beyond that, gas giants, Jupiter, Saturn, Uranus, Neptune, and they all move in circular orbits. But tell us a little bit about some of the oddball solar systems that we have found, where the planets move in highly elliptical orbits, and Jupiter, instead of being way out there, orbits near the orbit of Mercury. So tell us a little bit about other planetary systems that are quite different from ours.
Yeah, there's a lot of them, and to me, this is what's most exotic about the exoplanets. We used to think the gas giants had to settle kind of out toward the cool part of the solar system. Nothing could be further from the truth. We have found many what are called hot Jupiters. Imagine taking this cold, giant, fluffy Jupiter of ours and moving it to a third of the distance between the Sun and Mercury. That's what we're looking at with hot Jupiters. Many of them are so close to their star that their year lasts for a matter of days, sometimes even hours. In the extreme cases, their atmosphere, which is huge, strips off like a great comet tail. So we actually can see that in some of these light curves. We can see trails of material coming off of these giant worlds. So, and some of the Earth-like worlds out there may not be planets at all, but rather may be moons circling Jupiter-like planets that are in that habitable zone, in the zone where you can have liquid water on the surface. So we may find life on moons before we find it on planets. There are planets bathed in radiation, planets that are super cold but that still may have oceans beneath, and one of the strangest sets of planets that we have discovered are super-Earths.
Welcome back to Science Fantastic with Professor Michio Kaku. Well, if you are looking for a gift to give to a loved one who perhaps is just beginning to understand the enormity and gorgeousness of our universe, get a copy of this book, Envisioning Exoplanets, Searching for Life in the Galaxy by Michael Carroll. He's both a science writer as well as a space artist. He's a member of NASA's art program, and he's won a number of awards from the American Astronomical Society and the International Association of Astronomical Artists. Well, when we last left off, we were talking about the enormous variety of solar systems out there, almost none of which resemble our solar system. And I remember that when the movie Star Wars came out, there was a controversial scene where Luke Skywalker looks up in the night sky and sees not one sun, but two. A planet Tatooine going around a double star system. At that point, a lot of astronomers began to snicker and say, "Ha! What does Hollywood know about celestial mechanics? You can't have a planet going around a double star system in a stable orbit. It would crash. It's unstable." Well, boy, were we wrong. Isn't it true that we see not just double star systems, but triple star systems with planetary systems, all sorts of oddball arrangements in outer space?
Absolutely. In fact, the nearest star to the Earth, Proxima Centauri, is part of a three-star system, and we have found an Earth-sized planet orbiting Proxima. It's one of these red dwarf stars we talked about. But this is very exciting because it's just over 4 light years away. You could, with some limited advances in technology, we could get some spacecraft there within 50 years. So it's true that multiple star systems can have planets. Another Earth-like planet, or Earth-sized planet at least, in the habitable zone has been found at a triple star system called Gliese 667, and it's just one of many. So yeah, you're right. That was one of the surprises that we have uncovered in these studies.
Okay, well, the number one question that a lot of people want to ask is, of all the stars in the galaxy, 100 billion, how many of them have Earth-like planets? Not really twins, because, of course, we don't expect to find a twin of the Earth, but something close to the Earth. That is, it has a rocky surface, perhaps liquid oceans, perhaps oxygen in the atmosphere. So of the thousands of planets, 4,000 that we've cataloged, how many of them are, quote, Earth-like or super Earth-like?
So there are dozens that are probably Earth-like. The problem is that our error bars are a little bit wide. In other words, there is some uncertainty as to how large the planet is and how far from its sun it is. But within that kind of spectrum, we are pretty sure that there are other Earth-like worlds out there, and that's very exciting. It's hard to make an Earth-like world. There are all kinds of factors that make our planet the way it is.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is Michael Carroll. He's a space artist and science writer, a member of NASA's art program, and he's won a number of awards from the American Astronomical Society and the International Association of Astronomical Artists. And if you're searching for a gift for a loved one who's perhaps just beginning to understand the enormity and the splendor of our universe, then give them a copy of this book. It's gorgeous. It's illustrated by the author with scientific commentary about exoplanets, planets orbiting other star systems in the universe. So the next time you look outside, the next time you look at the heavens, realize that somebody could be looking back at you, wondering, is there life on the Earth? Nah, no way. No way there's life on the planet Earth. Well, there's something called Drake's equation, which it was formulated by the astronomer Frank Drake, trying to estimate, of all the stars in the galaxy, how many of them have intelligent civilizations on them. He took the number of stars in the galaxy, divided by the number that he thought would have planets, divided that by the number of planets that have oceans, divided that by the number of planets with oceans that have life on them, and divided that by the number of planets that have oceans that have life, that have intelligent life, and he came up with a number of civilizations in outer space. Well, what are your thoughts? What are some of the latest numbers that have been bandied about now that it's been so many decades since Frank Drake originally proposed his equation? Any thoughts about the probability of intelligent life in the galaxy?
Yes, absolutely. First of all, I think the big question is there intelligent life on Earth? But
no way.
Yeah.
Wrong question.
Well, yes, we'll look the other direction. It's interesting to note that when Frank Drake wrote that equation, most of those variables were guesswork, and we've been able to fill in a few of those since then. Kepler has filled in a couple all by itself, the number of planets around stars and the nature of those worlds. So we can continue to guess, maybe in a more educated way, as to who is out there, if anyone, looking back at us. Enrico Fermi, who was a famous physicist, asked the question, where is everybody? Why aren't we, if there are so many planets out there that may be Earth-like, why aren't we hearing from someone? And that's a great mystery. But I think the numbers push us toward the conclusion that there must be life out there and that it's likely that there are intelligent beings as well. The big question is, why haven't we yet connected?
Well, that's a good question, given the fact that on average, every star in the galaxy has a planet going around it. So of 100 billion stars, we have on the order of 100 billion planets going around them. And so the probability of finding another planet that is Earth-like is incredibly high, numbers in the millions, and who knows how many of them have intelligent life on them. But what are your thoughts? I mean, if you were to speculate a little bit and a kid comes up to you and says, wow, I just bought your book, I mean, who's out there? What are you going to tell them?
I think the first thing I would tell them is it probably won't be like Star Trek. I think intelligent life will be maybe difficult to recognize. It's probably going to be out there. We're going to find it one day. And if it's a kid asking me, I will tell them that they may be the one to do it. They should pursue that.
Science Fantastic with Professor Michio Kaku. With us on the line is Michael Carroll. He's a space artist and science writer. Well, where we left off, we were talking about Earth-like planets out there. Now, on the downside, let me note that some of these Earth-like planets go around red dwarf stars, which are very tiny. But apparently, red dwarf stars, many of them have solar flares, gigantic solar flares that would be sufficient to wipe out any life on a neighboring planet. So that's a downer. But hey, you know, the universe is what it is. So what are your thoughts? Do you think they're out there? Do you think that SETI will eventually make contact with one of these intelligent life forms in the galaxy? What are your thoughts writing this book?
You know, I think SETI shows a great deal of promise. We have to be continuing that search, or we'll come up with an answer that's negative, unless we are visited by someone. But yeah, I think SETI is, if it's funded well enough and continues as it is and has some technological advances that we expect, I think it is likely that we may be able to hear communications between civilizations, or maybe even sense the presence of industrialized, highly technological sources. All these things are on the horizon, I hope. And I do want to give a quick shout out to the other artists in the International Association of Astronomical Arts who contributed to this book. There are paintings by a lot of my very talented colleagues there, so it's not just me.
Now, what about the future? We mentioned Kepler, we mentioned TESS, the workhorses of searching for exoplanets, and you just briefly touched upon the Webb Space Telescope. What's coming next?
Well, there are a couple of ideas. One is called Ariel. It's a European project called atmospheric remote sensing. So it would actually look at the atmospheres of exoplanets. There's a telescope called LUVOIR that would be many times the size of the James Webb. So it would be a gigantic construction in space that will be able to show us, resolve some actual detail on the surfaces of exoplanets. Some of these advanced spacecraft will be able to measure spectrally what's on the surface, what kinds of rocks, what kind of stuff in the water, what's in the atmosphere. All these things contribute to our understanding of that possibility of life. Is there an active biome there that's changing the environment? And then the likelihood of intelligent life.
Now, some people have noticed that surrounding Jupiter and Saturn, there are large moons like Europa and Enceladus that have liquid oceans underneath the ice cover, perhaps capable of harboring intelligent life. Who knows for sure? But some people say that these gigantic Jupiter-sized planets are quite plentiful. Each one has many, many moons going around it. And maybe that's where to find intelligent life in the universe. Not on places like Mars, but on places like the moons of gas giants, which are quite numerous and have liquid oceans underneath the ice cover. And NASA, in turn, is looking for probes that will one day put a submarine, perhaps, in the oceans of Europa. But if that's true, doesn't that vastly increase the probability of intelligent life in the galaxy?
It does, absolutely. In fact, it looks like the water worlds of our solar system may be even better candidates for life than some of the terrestrial planets. So water is the key to life, and NASA exobiologists are following the water to try to figure out where there might be extraterrestrial life. So these ocean worlds, if you have one Earth-like world in a system, it has to be in one location. But these ocean worlds can be throughout the outer solar systems, kept liquid by things like tidal friction, the gravity of their nearby planet, or interior heat. So these are places where we may, in fact, find advanced life swimming around in these dark depths.
Okay, and I have to ask you this question. What are your thoughts about people who say that intelligent life has already visited us in the form of UFOs? The Navy, for example, has been releasing videotapes of these objects that can travel 20 times faster than the speed of sound, that zigzag. What are your thoughts? We're closing up the show, so what are your thoughts in about a few seconds?
I would love to know.
Okay. Well, once again, our special guest has been Michael Carroll. The book is gorgeous. It's a great gift for someone who wants to talk about the universe to a young mind, just beginning to understand what's out there. Envisioning Exoplanets, Searching for Life in the Galaxy by Michael Carroll. Good day.